Welcome back, Algebra 3. Today we're in Lesson 27, and we're going to talk about related angles and signs of trigonometric functions. So we've done a lot of functions. We've done linear functions, we've done the exponential functions, absolute value functions, we've done the radical functions. We've done a lot of functions. So now we're going to talk about trigonometric functions. And what we're really doing is we are taking our reference triangles that we talked about, the 45, 45, 90 triangle and the 30, 60, 90 triangle that we use to calculate mentally the sine and the cosine as opposed to whipping out a calculator. Now we're going to learn how to put those together with vectors, the polar coordinates, so that we can get sines, the right location on the Cartesian coordinate system. So the location of those right triangles matters. That's what's going to give us our positive and our negative and our of where it is. Okay, it's not just a triangle out in space. It's going to have a place in the Cartesian coordinate system as a vector, and we are going to be able to give it positive and negative signs in relationship to where it's located. And in order to do that, we need to have that polar coordinate to tell us where the triangle lives. So what I'm going to do is I am going to just jump right into the first practice problem, and then we can talk about where it lives based on the vector, and then where it lives is going to tell us whether it's positive or negative, because it's going to be on either the positive side or the negative side of the y-axis, or the positive side or the negative side of the y-axis, the x and the y. And that is going to help us a lot. All of our rules for positive and negative, positive times positive is positive, negative times negative is positive, and positive times negative is negative. All of those rules still apply, except for it doesn't matter where, in what quadrant, or in where on the Cartesian coordinate system the triangle lives. The hypotenuse is always positive. So that is the main thing that you need to remember. The hypotenuse, which is the vector, is always positive. He's always happy. He's just happy to be alive. The hypotenuse is always positive. Or if you want me to write it out so that it sticks in your head better, I can do that. He is always positive and happy because he's just, he's just like that. That's his personality. He's a happy guy. So let's evaluate. I think what I want to do is go down here to the grid, because that's going to be a whole lot easier for me to get some accuracy on. So we have our first problem is 27.1, and we're going to evaluate 4 times the cosine of 135 degrees. So give me a minute, let me draw that up. All right, so I took a minute and made all our sketches out. So we have 4 times the cosine of 135 degrees. So to get the proper sign on this, we have to understand where that angle or where that vector lives on the Cartesian coordinate system. And at 135 degrees, it lives in quadrant 2. And quadrant 2 gives us a negative x, not x minus. Hello, Miss Tracy. We have the negative value of x because it's on the negative side or the left side of the origin on the x-axis, and it's going to be a positive y. So let me rewrite this. This part here, this is going to be a negative, and this is going to be a positive because the angle lives on the positive side of the y-axis above the origin where the x and the y cross. So this value, whatever it is a negative, and this value, whatever it is a positive. And we're going to use our reference triangle here to determine what that is. So we want to find the cosine of 135. So we have to remember SOHCAHTOA. It always helps to write that up here to help you remember the formula. And the cosine is adjacent over hypotenuse. So the cosine of 135 is going to be the adjacent, and the adjacent is, here's our angle is 45. So the adjacent angle is going to be 1. And in this case, that 1 is negative, right? We see it's a negative here. So it's going to be a negative 1 over here. And then the hypotenuse, which is what it's over, is a square root of 2. And remember, the hypotenuse is always positive, so he's going to be positive. So it's going to be a positive square root of 2. Now we can't leave it like this, right? Because this is going to be, it's going to be, what's the word I'm looking for? Oh, we have the radical in the denominator. It's going to be a complex number, and we want to resolve that. So what we're going to do is we are going to multiply this in order to get the cosine of 135 in a number, in a fraction that we can actually use. So we just put a square root of 2 over square root of 2, and we multiply. And then the cosine of 135 is going to be equal to a negative square root of 2, or we can go ahead and say negative 1 times square root of 2 over 2. So the cosine of 135 is that. But what we need is 4 times the cosine of 135. So we're going to insert a 4 here. So 4 times the cosine of 135 is going to equal negative 4 times the square root of 2 divided by 2. And that resolves the cosine, 4 times the cosine of 135 degrees is going to equal to a negative 2 times the square root of 2. And that would be our answer. And that is how we get the negatives and the positives, by keeping an eye on where this reference triangle lives on our Cartesian coordinate system. Okay, that's the only thing we're adding to this whole process that we've been doing, is learning where it lives based on the angle in the system, right? Figuring that out. Up until now, we've been told cosine of 60, cosine of 30, cosine of 45, just so we could use our reference triangles. Now we're getting greater and greater detail. So now we know where it lives on the Cartesian coordinate system, so we can apply the positive and negative signs as appropriate. So let's do another one. Let's do 27.2. And I'm going to take a minute and draw it up here for us, and then we can solve it, okay? All right, here we have 27.2, and we're asked to evaluate negative 2 times the cosine of negative 150 degrees. So remember, we can have a negative degree. It just means we start measuring the degree of the angle backwards. Instead of going in the normal counterclockwise position, which if you think about it, it's quadrant 1, quadrant 2, quadrant 3, quadrant 4. That's the sweep of our radar, so to speak. If we go backwards, then the angle becomes negative, right? So negative 150 degrees puts that vector here in the third quadrant. And the difference, this is 90. The difference between 150 and 90 is going to be 60. So the remaining degree here is going to be 30 in relationship to the x-axis, because remember, it's always in relationship to the x-axis. So it's a 30-degree angle right here. Boom. So now we can find the cosine of this 30 degrees here. So this would change to the cosine of 30. So it would be negative 2. And this would be times the cosine of 30 degrees. And that is going to be equal to whatever this is equal to. So we have our reference SOHCAHTOA. That's going to be the adjacent over the hypotenuse. So the adjacent of the 30, which is this one right here, the adjacent is going to be -3. And notice both of these are negative. Our adjacent and this is our adjacent, and this is our opposite. They're both negative. So this is going to be a negative square root of 3 over the hypotenuse, which is, let's see, 2. The hypotenuse is 2. So the hypotenuse is always positive, so it's going to be a positive 2 there, right? So now we're going to insert this -2 here because we're multiplying it times this, so we need to multiply this times this because this is the cosine of 30 degrees. And it's negative because of where it's located on the x-axis. So what we can do is we put this over 1 and we get negative times negative, that's a positive 2 times the square root of 3 over 2, because 2 times 1 is 2. Those two cancel. So -2 times the cosine of negative 150 degrees. We go back to the original angle here. That is going to be equal to the square root of 3. And that is our response. All right. Now, this is not that hard. You see, there's not a whole lot of math. It's more thought process and drawing of the sketches and figuring out where it lives than it is actually doing mathematics. The mathematics part of it is easy. This is the part that takes a minute. So let's do another one. Let's do 27.3. And I'm going to go ahead and just pause and put it all of this up there at one time, and then we'll solve 27.3. All right, so here we have, this is our last problem. Evaluate 5/3 of the cosine of 300 degrees. So first we sketch it out. We figure out our vectors at 300 degrees. And 360 minus 300, it's a positive angle, so we know we start measuring the normal way. We go the same direction we're used to. And it brings us around to here, 300 degrees. The difference here is going to be 30 and 60, right? We got 90, 180, 270, 30 more. That leaves a 60-degree vector in relationship to the x-axis. Hypotenuse is always positive, and we're on the positive side of the x-axis, and we're on the negative side of the y-axis. So that gives us our unit of reference for these right here. And actually, I think what's going to be easy for me, and it might be easy for you, is if you go ahead and apply these values to the values that are on your reference triangle. So between the 60 and the 90-degree angle, we have a positive. So that's going to be a positive 1. Between and the hypotenuse is always positive, right? And between the 90-degree angle and the 30-degree angle, we have a negative sign. So this one's going to be negative. So that might help you solve that problem a little bit faster than having to go back and forth between the two. So maybe add that to your process in regards to after you draw this to figure out where it lives, and then you draw this to remember your values, then take this and put the signs on your reference triangle for the sake of not having to go back and forth when you write out the problem. So now we have 5/3 times the cosine of 300, which is going to be the 60-degree. So if it helps you to write 60 degrees, that's fine too. Or here's what you can do. Here's what you might want to do. Just do the cosine of 60 degrees first, and then drop it into the problem. So cosine, so ca, it's C-A-H. So that is going to be adjacent over hypotenuse. So the adjacent, this is the angle we're dealing with because it's the 60-degree angle. So the adjacent one is going to be the positive 1, and that's over positive 2. So that's going to equal 1/2, positive 1/2. Okay, so now we can do this. So 5/3 of the cosine of 300 degrees is equal to 5/3 of 1/2, which is going to be equal to, and it's both positive, so that's going to be equal to 5/6. And that is our final answer. How easy was that? So I think putting the signs on our reference triangle when we get it drawn is going to be a big help to getting this done faster, because then you don't have to go back and forth and figure out which one is positive, which one is negative. So think about doing that in the future, and then you can just go off your reference triangle. You don't have to refer back to this. This is only good for telling you which ones of these are positive and negative anyway, because it's telling you where it lives on the Cartesian coordinate system. So that was not super difficult, not super hard at all. In fact, I kind of enjoyed lesson 27. I don't know about you, but it didn't take a whole lot more thought to wrap my head around that. And that's all we have for lesson 27. So I will see you in lesson 28.